Okay, here we go again. So right now we will have Eric Shups. So Eric has been working with SharePoint, I believe, since 2001. And so we can imagine again, like we had with Bill. So we can, any questions inside SharePoint will be not a question for Eric. Eric, are you there? Eric, I think you are muted. We're still not hearing you. So it seems that Eric is having a little bit issues with the sound. Okay, let's see if Eric. Eric, I can see here in Teams that you are muted. Is not only any is not probably the issue is not regarding the sound. You need to unmute yourself. So can you check the settings on your Teams? If you go to the device settings, check just the microphone. So here I can see that you do not have, that you have the sign that you are muted, but probably can be an issue regarding the sound on your side.
Eric says in the chat that he's not muted.
Yeah. So probably the issues regarding the settings. I don't know. So it is switch off, and then probably see it will be switching on again.
I think he's left the session.
So probably can be an issue regarding the Teams. Let's see. Yeah, Bill, we did not have questions, but can I make you, and since that we are waiting from Eric, can I make you a quick questions regarding the framework regarding SPFX? So is there any specific framework that you like to use besides to use native JavaScript? Because by default you have React, right? And you have a few Yeoman generators that they have include Angular and Vue.js as well. But by default, only React and Knockout is added to the template, to the Yeoman template.
Well, yeah, the Yeoman template that Microsoft supply only have those two options.
Right.
But there are other Yeoman generators. So there's one that the Patterns and Practices one, which has a few more options. Or the other thing is, if you say you wanted to use Angular or Vue, which are two popular frameworks, then you could go into that repository that I showed in the talk, and you could find an Angular example in there as well, or a Vue example that somebody's contributed. So, and use that as a starting point rather than the out-of-the-box Yeoman generator. But I do prefer React. I mean, that's my choice. Because it's got the UI fabric and it's what Microsoft are using to build these sort of modern SharePoint pages. So the sort of framework's there already. So it's like, unless you've got a reason to use Angular, like you've been doing Angular development for the last 10 years, you probably want to stick to Angular. That's understandable. Right. Yeah. But if you have a choice and you think, which one shall I use? I would recommend React at the moment.
Seems that we have Eric right now. It's back. Eric, can you hear us? I see right now here that you are not muted. At least Teams say me that you are not muted.
Oh, I heard him.
Yeah, but very, very far away.
But you sound very far away, Eric, but then again, you are.
No, we cannot hear you.
What about now? Still very faint.
Yeah.
I'm having to go through the browser. I have no idea what's going on.
It's better.
That's way better.
Yeah, way better.
I know. Hang on.
Okay.
Now it's much better.
Oh, that's better.
Now it's perfect.
Does that work?
Yeah.
Yes, it's perfect right now.
Okay. One more thing.
Okay.
All right. How about now?
It's still perfect.
How is that?
Perfect.
Awesome. Okay, 3 different audio devices. Client to browser.
Yeah.
Welcome to the world of Teams. Yeah.
Yeah.
But now with the ad,
is still the same.
now with the ad is even better.
Do what?
With the ad, with your ad, when you put the ad on, was better.
Oh, it works better with the hat on.
Yeah, it's like
The voice is still the same. So the voice is still the same. You don't even.
All right, we're going to try and share here. I'm doing this through the browser, so bear with me here. But hopefully okay. This will work.
Okay, when you want, Eric, the stage is yours.
All right,
and
Bill, can everybody see my screen?
Thank you.
No worries.
Oh no! Now it won't share my screen.
It happens.
Oh man. It's that kind of day. All right, hang on just a second. Be right back. Hang on.
So it seems that Eric has another trick behind. Hi, Rodrigo. How are you? I can see you right now. But you are muted, right?
Yes.
Yeah, I'm muted. Jesus.
You are
that will
muted.
be the phrase for the entire conference. You're muted, right?
Yeah.
Okay, now.
There we go. We have Eric again.
Oh man.
This is live. Things happen.
Just in a day. All right. It's all Team's fault. All right, let's see if we can share the screen. Yes?
It's coming. There we go. Perfect.
Ah, success. Okay, everyone has left now and gone off to get a beer. All right, now let's see if we can do this. So thank you everybody for joining. Sorry for the technical difficulties. Of course, we need to mention our sponsors because we can't do this without them. So thanks to all of our sponsors. For those of you who don't know me, here are all the ways to get in touch with me. If you'd like to reach out, I will publish the slide deck immediately after this session up to SlideShare, so you can go grab it and get all of this information. So we were going to have to move pretty quick through this presentation anyway in the time allotted because it's a really big topic. Now, of course, with the technical difficulties, we have even less time. So I'm going to go pretty fast. I apologize for that. Understand that there's probably some non-native English speakers, and my English is bad enough as it is. So I will do my best to try and get through everything in the time allotted. and also make available any of the code that we look at here so you can go through it later at your convenience when we're not in such a hurry. Okay, we're going to talk not so much about the development process, although we are going to look at several code samples, but what we're really focusing here is the authentication and authorization layer that brings all this together. The biggest change probably from your development experience moving in the cloud is the different ways that we authenticate and especially how we authorize apps. And this applies across the entire development stack for SharePoint, Office 365, Teams, and Azure, with the exception, of course, of the legacy full trust model. But everything from add-ins to SPFX to building things in Azure with Azure Web Applications relies on a similar set of authentication and authorization methodologies to make all the various different pieces talk to each other. And this can be challenging. In fact, in working with new developers onboarding to the platform, or SharePoint developers coming into the cloud, or even legacy .NET developers moving into this stack, the biggest challenges that we have are around authentication and authorization. Specifically, how do I authorize my applications to work with Office 365 and Azure? How do I move from my on-premises traditional MVC.NET applications into the cloud and effectively work with the same identity stack I was using on premises? And how do I manage all of these identities, considering that my on-prem Active Directory users aren't actually the same identities in the cloud? They're slightly different. They exist in a different repository, but they're synchronized between the two. So how do I effectively work with those user types? What are all these token things, and how do I manage tokens? What's the right flow that I should be using for my application? And am I using mobile apps as part of my deployment, and how does that fit into the picture? And all of this can be really confusing. So let's start at the bottom of the stack with authentication. And let's set right up front that authentication and authorization are two entirely different things. Yes, we must authenticate to some sort of identity store. That can be on-prem, it would be NTLM versus Active Directory. In the cloud, it's going to be FBA SAML to Azure AD, or it can be another type of identity store that you're using that implements OAuth type of protocols for authorization. But at some point, the user has to put in a username and password. If you're working inside of the O365 stack, they do that when they first authenticate to Teams, or they go into SharePoint, or they go into Sway, or one of these other first-tier applications. All of those, by the way, are Azure AD web applications that do the same thing that we're going to look at in our demo here in a few minutes. Now, if you're doing SharePoint apps, which is a bit of a legacy consideration, there's slightly different way of doing things, or more options. The authorization piece is a little bit hidden behind the stack until you get to your code, but we're going to focus primarily on SharePoint Framework and Azure Active Directory, since that's the more modern going forward implementation. SPFX gives you some advantages. It inherits context from the page that you're on. So when you start working with your components, as you saw in Bill's presentation, when he was passing his properties into React, he was getting the context, setting it up, and passing it on. And that's because SharePoint Framework is context aware when the component is deployed. But there are still other considerations that you need to concern yourself with. SPFX is not actually truly a single sign-on implementation. When you work with the graph, when you work with Azure AD, as we're going to see in one of our demos, there are extra steps that you need to take to authorize your component in that framework. And there's some behind-the-scenes settings that need to be done when you're using things like the Graph HTTP client, or especially when you're using the AAD HTTP client. We'll look at how we put those together in our code and what the back-end pieces are in Azure that we need to set up. When you are building Azure AD web applications, and whether you realize it or not, you are going to be deploying an Azure AD application when you work with any of the Azure AD endpoints, especially from SPFX, where you have actually a hidden Microsoft application that gets deployed. And also when you deploy your own endpoints that you'll be connecting to, you are going to be creating and deploying Azure AD components. There are two ways to do this, either in a single tenant mode, which means just your organization's Active Directory, or in a federated multi-tenant mode, where your tenant is the master, if you will, of the component, but other users in different tenants are federating to yours and deploying an enterprise application in their tenant that actually is hosted in your tenant. So that's what we mean by single tenant, multi-tenant. And the setup for your applications can be different depending on which one you choose. The advantage of deploying native Azure AD web applications is that they are truly single sign-on. So you can switch, for example, from O365 SharePoint to Sway or to Teams or to Planner. All of those are native Azure AD web applications. So there's no additional authentication that's required. They just pass seamlessly to each other. You do have to consent to these things being deployed in your organization. That can be done administratively on a tenant-wide level, or can be done individually by users. If you're going to be connecting to external repositories or services such as SharePoint, you have to do specific certificate exchange for SharePoint because it contains its own backend token issuer. But you will also, if you are connecting to external APIs, have to do some additional configuration. I'll show you an example of how we do that. So let's start with the very basics. You have an Azure AD web application. You're going to deploy this. This is a very common scenario for moving .NET applications up to the clouds. You're going to republish that cool MVC app now as an Azure AD application. Good news, you're not going to have to rewrite a lot of your code, but you are going to have to change the authentication and authorization methodology that you use. So we're going to switch over to traditional legacy, if you will, Visual Studio, and look at a web forms application that I built. Now, if you've ever sat in on my Building Azure AD web application session, this should be familiar to you. This entire application is in my repo at github.com/eshups, so you can go pull this down. And what we are going to do now in our application is when the user logs in, they're going to have a sign-in button. And that sign-in button is going to authenticate not to NTLM, not to an FBA, but to Azure Active Directory. Now, to wire that in, the Visual Studio templates will do this for you when you pick your authentication type and give you some basic scaffolding. What they don't do well is scaffold up a multi-tenant scenario. So I built in a multi-tenant framework here to show you how these things are built. But let's look real quick at what happens when you sign in to the application. This is actually a relatively straightforward part of the code. You have a sign-in button. It's going to read some configuration from the web config. I'll show you that in just a second. And what it's going to do is construct a URL that it's going to pass to a well-known endpoint that's defined in your web config. When Microsoft receives that, it's going to show the user the Azure AD login screen that we're all familiar with. Once the user has authenticated, it's going to post back to a URL that you've given it here in this callback URL. This is one of the URLs for your application. It has to be defined in your application properties in Azure when you set up your app registration. When it posts back, it sends a post with something called a W result, which is a block of XML that you have to parse to do something with. But in order to make these pieces work, you first have to have the OpenID Connect framework set up in your project. As I mentioned, if you use the Visual Studio templates, this is done for you, and it will scaffold up a web config that has some properties, starting with things like a federation metadata location. Now, take note that the web config that I'm showing you is for a multi-tenant application. The difference between a single tenant and a multi-tenant in your configuration is that in a single tenant, your login, your federation location will be your tenant ID because it's always logging into the same tenant. So this would be your ID of your tenant. You don't actually have to specify this in a single tenant scenario. It assumes that the connection that you've published to is a single tenant scenario. If you only need to specify this when you're doing a multi-tenant configuration, because it doesn't know where to go. What it does need to know is your Active Directory domain of the tenant where the app registration is published. So be careful when you're naming your domain. Don't make it something silly or something off-putting to potential customers, because they will actually see it in the consent screen that gets displayed. And it's also driven here in the URL. You will then need a couple of additional pieces of information. The realm, this is a app ID URI. It gets generated for you by the templates, or you can see it in the Azure configuration for the app registration. And we're going to go look at that here in just a second and see how those pieces are put together on the Azure side. You then will need things like your client ID and secret, depending on the flow that you're using. The common endpoint, this is your common login endpoint here, and potentially your tenant ID, again, depending on the type of flow. If we go down a little further in the web config, you'll see that there's some additional setup that's required. One of the things that you have to do in multi-tenant is you have to track the tenant IDs that are coming back to you from that W result response when the user logs in. This is because it will contain things like tokens, access tokens that you'll need, or authorization tokens that you'll need to exchange for access tokens. You'll also potentially need to store things like refresh tokens, again, depending on the type of flow that you're going to use. You'll need a database. Doesn't matter what kind of database it is, as long as you have some place to store the tenant IDs and refresh tokens that are coming back to you. I have a little config SQL script here that will set up that for you. It's in the repository already. If you want to run this, say, in Azure SQL, you can set this up real quick. The default templates assume that you're using Entity Framework, so everything is set up with Entity Framework code first. You don't have to do that. You can have any type of database that you want, as long as you wire it up. And here we have something called an issuer name registry, and this is pointing to the class that manages your database. So it's going to do things like this try add tenant here, where we're putting a tenant into the database so we can store the tenant ID and its sign up token. So you'll see it's doing a little bit of token management here. That's because these will expire and need to get refreshed. So a user at some point will need to log in again. I'll show you a slide in a few minutes about what those token expiration lifetimes are, so you know how to plan for that. Additionally, in your web config, you'll have to set up your WS federation. You'll want to point to the common WS Fed endpoint. This is the, I don't care where you're coming from, I'm going to show you the same Azure AD login prompt, but it's going to have a little bit of additional information behind the scenes, which is your realm for your app ID URI. These are unique across all of Azure. In your sign up, that's what you're reading here when you pick out the WS Federation config, so that it knows what to properly pass in as the right URLs. Once the user has authenticated, then what's going to happen is you're going to get that post back from Azure Active Directory telling you, hey, this is the information I have for the user just authenticated. Now, unfortunately, there's not a ton of information there. You'll get things like the tenant ID, and you'll get the user ID. So if I have a little helper function here to parse that out in the XML. So if I go to the definition of that, you can see that I'm doing a little link to XML, and I'm getting things out of the response that comes back, including the user email address, the tenant, display name, etc., and storing those for use elsewhere. You don't get any context, so you don't know where they're coming from. If, for example, you wanted to call back into a SharePoint site, you'd need to have some configuration telling you what URL to go call, or have the user enter that information, because it doesn't know. Azure AD applications globally scoped across the tenancy. They don't have any context information other than what they provide you here, which is pretty limited. Mostly the username, email, and tenant ID. When you have that information, you can then call our issuer name registry function here, which is where we do the triad tenant. We're going to put this in the database and we're going to store it. Again, all of this is scaffolded for you with Entity Framework if you're using the Visual Studio templates. If you're using something else, and this can run on any stack, it doesn't have to be .NET, then you'll have to write these functions and capabilities yourself. If there's not already a template for them in order to put all these pieces together. Now, bear in mind, again, I'm showing you the most complicated scenario for multi-tenant. If you're doing single tenant, this is a bit easier. You don't have to track tenant IDs. It's a much simplified flow process for the authentication. But this is your single sign-on piece that tells your application the user is authenticated into Azure Active Directory. You can now display information for them. What you don't get from this is the type of context that you would get, say, from the SharePoint framework. And we haven't done any sort of authorization to, say, talk to the graph, which is a different set of activities. So quickly, before we jump back over into the other pieces, let's see if I can get back to my Azure AD instance. So let's go to Azure Active Directory, and we will look at our app registration for this app and some of those components that we just viewed. So when we look into our authentication, we have things like our redirect URIs. Redirect URIs are a white listed group of URLs that are allowed for that W result to post back to. If it's not in the list, you're going to get an error saying, hey, you cannot post back to this. Now, localhost should only be used for development, so you should have a AD registration for development and an AD registration for actual production. That way it can't be spoofed. We can also grab things like access tokens and ID tokens out of this to get sent back to us, generate client IDs and secrets. Remember, when you generate a secret, you have to grab it here. This will support specific flows and also set up our permission for things that we're asking for. I'm going to show you an example in a minute of how we call the graph from that same application. Here are the permissions that we're requesting from the graph, and they have to be enumerated. If you're going to expose that, you're going to need to set up your scopes and have your app ID URIs available here. I have another version of this where I have all of those things set up, but we're also going to look at an SPFX component here in a bit where we're doing essentially the same thing. So these are some of the configuration that we have to do in Azure when we register our Azure application to wire together our config that we have in our code and what's already registered in Azure. So for purposes of time, we're not going to go through an Azure AD app registration. There's plenty of documentation on that you can walk through to see how those pieces are set up. So let's move now from authentication over to authorization, because there's two different pieces happening here. One is the user has a valid Active Directory account and they are authenticated. We've validated their identity, but that's not enough. We must also make sure that they are authorized by that identity store to use our application. Thus, the need for application registrations, permission scopes, and tokens, where we say, okay, the user is authenticated, but now they want to use this widget that we've published. So we have to make sure that they're authorized. That's completely independent of your authentication. And all of this is done through an OAuth mechanism that includes permission scopes, grants that we've provided for the user. Now, all of you have seen this stuff in action. In an OAuth flow, you have gone through this process, whether you realize it or not, of exchanging tokens to get access to resources. You've done it in Facebook, you've done it in Twitter, you've done it in Office 365. Whenever you see a login that comes back with a screen that says, do you give this application permissions to read all of your information, record your phone calls, send everything to the government, et cetera, all of those are permission scopes defined by OAuth. And you have gone through either a two-legged or a three-legged OAuth flow to get there. And what's happening behind the scenes is the application is talking to the identity store, in this case, Azure Active Directory, and it's doing this token exchange. And that Because the application that you've published requires one of these types of tokens, an access token or a refresh token, then you are going to need to exchange those tokens within your code, dependent on the type of flow that you're using. Now, take note as we're going through the presentation here, and you'll see on the slides when I publish them later, at the bottom left-hand corner are some links to go and get reference material. There's quite a few of these in this presentation. This is really a workshop that we've condensed down into 55 minutes, or in my case, 45 minutes with technical challenges. So you can go and read each of these resources to get more information on the bits and pieces that I'm talking about here, and do some additional reading. This is not lightweight stuff. If you're new to it, there is going to be a learning curve, and it's going to take a little bit of time for you to get comfortable with how all these various components work together. Don't get frustrated. It will get easier as you go through the process and have sample code that you can reference. So let's talk now about the 3 different authorization flows, because these are critical to get your application working in the manner that you expect. So there's 3 primary ones. The first one is called, yes, the authorization flow. I know the naming is terrible, but this is designed for long-running type of applications, or things where there's not a bunch of user interactivity. You're not expecting a user to log in and put in credentials and interact with the application on a regular basis. So that could be something that you're running in a function, or a webhook, or some long-running thing running on the back end. This is where you will use refresh tokens. So access tokens have a short lifetime, but you can exchange them, or you can get new access tokens using something called a longer-lived refresh token as part of the process. A client credential, though, is more like what you're used to. You're used to working with Teams or Office 365, where there's a login, and it's going to time out at some point. You're going to be required to log in again. This is the client credential flow. There's also a third flow, which is called an implicit flow, and that is for JavaScript-based SPAs or mobile applications. We don't want to have things like shared secrets and certificates in JavaScript where they can easily be picked up and spoofed. There's no server behind the scenes controlling those. It's all client-side, and so it's easily interceptable. Therefore, we have something called the implicit flow. The implicit flow relies on ADAL.js or IMSAL.js on the back end, which are JavaScript libraries published by Microsoft that do server communication, but with a singular endpoint that you don't control. So they're abstracting all of that stuff for you out into the cloud to make that work. These are much shorter lived in terms of tokens, and you can expect a lot of additional logins when you're building something with an implicit flow. There's also a change you have to make to your manifest to specifically allow that to take place, unless you're using an SPFX component, in which case it's kind of all built for you. Now, all of these flows are designed to do nothing more than token management for OAuth, because OAuth is a token-based authorization scheme. And this token management process will be slightly different depending on the type of flow that you are using. Each one of these type of tokens has different expiration parameters. For example, access tokens default for only 60 minutes. Their maximum is 24 hours. If you have users that are working in an application and you expect them to be going longer than that, which would be unusual, but it could happen, expect them to get logged in again, or you'll need to use some code hacks like a hidden iframe that's constantly refreshing in the background to extend that token lifetime. Now, that's not great for long-running applications. Therefore, we have the authorization flow that uses things called refresh tokens. When you log in to Azure AD, you are going to get something called an authorization token. That authorization token isn't really good for anything, but it can be exchanged for an access token, And when you get an access token, you also get something called a refresh token. A refresh token is logged by Azure AD and held on the back end. So it's sort of a ticket, like when you go to a club and you get a hand stamp that says, okay, this is only good for today. Well, sometimes you have a weekend long rave and you get a bracelet, and that bracelet lets you in all weekend long. And that's the difference between, say, a refresh token and an access token. Refresh tokens are for a longer period of time, and your application can send the refresh token to Azure AD and say, hey, give me another access token. I'm still good. Azure AD will respond and say, yes, here's your new access token that you can use again. Because all of your apps require an access token, the refresh token just allows you to get new ones. You can see some of the other tokens that we have here. There's more than that. You can go to the reference material to get more information on that. So now let's go back to our sample application. And in our sample app, what we want to do is, in addition to logging in via Azure AD, we also want to call the graph. And in this case, I'm just going to read my own calendar and get my own calendar events. Well, logging into Azure AD does not give us an access token, only gives us an authorization token that basically says you're authenticated. Now I need an access token in order to talk to the graph. So what I'm going to do in the graph is I'm going to do something very basic, and I'm just going to call this endpoint. Now, this isn't as pretty as Bill's example from PNP where he said graph.me and called the me endpoint, but I'm actually going to call the multi-user endpoint here, and this is the URL that I'll use. And instead of me, which always does the currently authenticated user, I'm going to pass it in the user ID. Remember, when they logged in and we got the W result back, in the XML, we have the user principal, which is their email address. We can now use that information to pass that to the graph, and if we have permissions to read the user's calendars, we can pass in that user ID and get back their information. So I can call any user as long as it's been authorized in Azure AD for me to do so. So I'm going to pass into this URL. Now to get, I first need an access token. So I have a authentication manager class that I've created here as a utility. And what it's going to do is it's first going to call an authentication context with the login URL and the tenant ID. Now, if I scroll up a little bit here, you can see that I'm pulling that information out of, in some cases, my web config. We looked at that setup. There's a reason I had the tenant ID in there. That's so I can pass it in this authorization context. The generalized login URL, login.windows.net or login.microsoft.com, either one will work. What I'm doing here is I'm getting an access token, which I'm going to need to call the graph. So I'm going to call this auth context, and I'm going to acquire token async. These are built in if you're using the OpenID Connect assemblies that are available to you in .NET or .NET Core. And I'm going to start creating an authorization header. When I get this token back here in my authorization token, I'm saying, okay, I'm setting this up. I'm going to want an authorization token in this tenant for this application. It's going to respond with that. Now I need to get my access token, so I'll set up this authorization piece, and I'm going to pass it in, and I'm going to get my token back that I can then use. So in my result here, I'm going to read that response and get back my token. Now you'll notice that, sorry, in this result here, you'll notice that I have a little catch around the expired authentication token. This is so that I can refresh that access token without the user having to authenticate again. My authorization context is longer lived than the access token. So each time I go to refresh the page, rather than popping a login dialog to the user, I'm going to do this behind the scenes, and I'm going to look for the expired authentication token, and I'm going to automatically refresh it and send it back. Okay, so a little trick we can use to not have to authenticate all the time in an Azure AD application. Once I have that, then in my graph call, see here I'm setting up my auth manager right? Setting up my async task, getting my authorized response, and now I can make that call to the graph endpoint to get back my list of results. So there I'm calling my task. Here's my result. And I'm going to deserialize the response that I get back and just take that and build some HTML that has things like the date and the subject and whatnot of the calendar. And you'll see that I'm using OData to specifically ask for that data in my call and not just get back a big block. So this is an example of, I want to call the graph, but even though I'm authenticated to Azure AD, I can't just directly call the graph because I'm authenticated. I still have to authorize using this token mechanism. Now, let's move on to SharePoint. How do we do this when we're in a framework context? Well, as you can see by this slide, it's a little bit more complicated. SharePoint Framework runs in JavaScript. Therefore, it is an implicit flow. We are going to have to use the ADAL.js or MSAL libraries behind the scenes. Now, if you're on version 1.4 or lower of SPFX, you will call this directly. If you are in 1.4 or higher, you can use the AAD client or Graph client or SPHTTP client. They do the same thing. It's just all done behind the scenes for you, so you don't have to do it yourself. Now, on the Azure side, there's a bunch of moving pieces to make this work. First of all, there's something called the SharePoint Online Client Extensibility app. This is an app that gets automatically deployed in your tenant that enables SPFX to work for these custom calls to the graph and client endpoints, okay? That's there. You may not realize it, but if you go into Azure, you can see it. That handles all of your scoping requests that you're going to put into your package solution JSON. These are tenant-wide. It happens for the whole tenant. So when you ask for a set of permissions, we looked over here in Azure AD at the permissions that I was asking for in my component. Now I'm going to jump ahead of myself a little bit and look at the permissions I'm going to call from SPFX. So I'm calling user.read for Active Directory. This is the very basic component information that you would be asking for. It's the default that's required. But if you remember from our earlier example, I'm also calling the graph. These are the permissions that you will have to explicitly request in your application manifest to make this work in SPFX. When those are granted, it's not just for one app, it's for the entirety of the tenants. You need to bear that in mind when you're asking for permissions, because you're giving this behind the scenes app those permissions for the whole tenant. There's also another step that has to be done in the SharePoint portal. When you deploy a new SPFX that has these permissions, it's going to create a permission request. And that is in the SharePoint Admin Center. So if I go into here and go to my SharePoint permissions, let's go to my admin. We'll go over here to SharePoint, and you'll see this section called Advanced. Look under API access, and whenever you deploy a component, it will automatically take those out of your manifest and put them in here and say, I need to make this permission request. You can see here, here's the default Azure Active Directory read, and here's the one I'm going to ask for in a minute when I show you the code. This has to be done in SharePoint to enable this to work. So two places that you have to manage these permission configuration, right? And each page is an app, which is kind of a weird thing that happens when these things are deployed for your permissioning. So there's some stuff you have to do, like with cores, setting up an API to facilitate that. Okay, so we're going to set this up in an SPFX component. Let me show you a quick demo of what we're doing, and then we're going to look at the code and finish with how these pieces hook together for this particular app. Now, in my SharePoint portal, so let's go back here. We've looked at the admin center already. So let's go to a SharePoint page, and I have an SPFX component that's doing some cool stuff here. It's calling a function that is hosted in Azure Functions. So it's a external API. And what this is going to do is it's going to exchange currency for us, if I can get this app to load. There it comes. And in real time. So a couple things happening here. I have a function app that's running. So I have to have the API exposed. In order to expose it, I have to create an Azure AD application. That's what we just looked at here in my all apps. That's this. So I have to set it up here and register it in Azure AD in order to make it work. And to do that, I have to do my permission setup, and I also have to expose my API with something called this user underscore impersonation endpoint that you're going to see in the code. So I have to set that up here, and I also have to give it some information to make it work in the manifest. Because it's implicit, I have to go in here, and OAuth to allow implicit flow has to be set to true, because this is technically a JavaScript SPA. Okay, I'm not really worried about client IDs and secrets so much, although I have one set up here because it's not going to be using that in the JavaScript code, but these are things that I set up on the back end. Right? So now I have my app published and it's ready to go. Note that in my API permissions, you don't see that user impersonation. That's because it's in the expose API section. But to make this work, and I'll just show you that this is actually functional and calling out to the graph endpoint, we're going to have to get all these pieces wired up and put together. So you can see now I'm converting dollars to British pounds here live in the conversionator, and it's not asking me to authenticate. It's not asking for a user login. That's because I've done the setup already in my Visual Studio code. So what I've done here, this is a basic React app, not fancy function-based stuff like Bill had in his, so it's a little bit messier in terms of the code. So Bill will not be approving my messy code here for my React component. But in setting up the React component, there's a couple of things that I have to do. First of all, in my package solution, here are the permission scopes that I'm asking for. You need to add this in under Web API permission requests. I'm sure you have, Bill, seen worse. If you all aren't monitoring the chat, Bill was responding. I have to set these up for the app itself. So here is the resource display name of my application and that user impersonation scope that you saw in the SharePoint permission request, and also the Azure Active Directory user.read permission scope. So I have to request this. When I deploy my application, it's automatically going to put that request for these permission scopes to be approved into SharePoint. Now, in my code, this is actually fairly straightforward. I'm just setting up some React components that have a drop-down and the entry box for changing some pieces. So there's nothing really fancy here in setting this up. You can see my JSX here that I'm rendering to make those available. So nothing kooky there, pretty simple. Down in my Get conversion, though, when I click the button, this is where the magic is, where we're calling our endpoint. So to make this work, I'm going to make a call to the AAD HTTP client factory. To get there, of course, I have to import AAD into my application so that I can use these components. So there's my client response, and my client options. Now I need to set up the client options because I'm doing a post and not a get. So you can see me set up my data here for my post in JSON. And here is my request options with my headers and my body. Now I'm going to chain these promises together, call my AAD client, and call my endpoint. So the first thing I have to do is I'm going to call get client on endpoint. So this is my Azure function that's been deployed. This can be the ID or it can be the URL. Easier to understand the URL, so we put the URL in here. I'm then going to call the endpoint, which in this case is API convert currency, using a post and the AAD HTTP client request options that I've set up, and getting the response back. So then I parse that and I set the state so that we'll automatically update and you can see the results. Now, this code is fairly straightforward here to pass it in, but it's all dependent on me having the function configured and deployed, and more importantly, having the Azure AD application registered with the right permission requests and the right URL configuration, and having the permission scopes that have been requested and approved in SharePoint. With those behind the scene pieces working, then our relatively simple app code here in SPFX functions correctly. When you deploy it to the app catalog, it will automatically then put that permission request into SharePoint for you, as we saw. Sorry, I navigated away from the page, as we saw in the permission requests, so that it can be approved. Until that's approved, this is not going to work. It will throw you an error saying it's unauthorized, or there's a permissions scope error because you haven't properly authorized that to occur. Okay, there are lots of different permissions that you can request. Here where we're talking about the graph, I'm giving you some examples of what those graph requests are. I know we only have 4 minutes left. In Azure AD, when you're requesting permissions, you can request them this way, and it will show up in your Azure AD application, or you can actually go into Azure AD, and in your permission scopes, you can grant them here. And you can see there's a whole ton of them. You can pick things like, let's say, SharePoint, and you can go and look at delegated or application permissions, right, and see what you need to get. Now, pay attention to this column, admin consent required. This is very important, because if you ask for a permission that requires admin consent, and it will tell you, like that user read that I had for reading all calendars, that requires admin consent. Tells you yes in this column. That means that an administrator must consent to the application. So if you are doing a multi-tenant deployment, the user, the end customer, if you will, is going to have your app registered in their enterprise applications. Okay, here it is. Here's my conversionator right here. In order for that to function, they are going to have to do administrative consent, where they click somewhere in here. I forget where, permission. There it is. This big button that says grant admin consent. Until that happens, your application won't work. So beware of the permission requests that you're making and whether or not they require administrative consent to function. Okay? And that's why I have this in red right here. Pay attention to what you're asking for in these permission requests so that the user doesn't get an error when they're asking for that. This is very easy to get wrong when you're specifying them in your application manifest, because it doesn't tell you. It only tells you when you're looking at it in Azure AD. So I always recommend that you go and look in the Azure AD permission scope so you can see what's happening. And remember that these permission requests are tenant scoped when they're approved. So whatever you ask for here gets applied to the entirety of the tenant for that permission scope request that happens from your SPFX component. You can also, if you look, you can see the SharePoint Online Client extensibility. It's actually in your Azure AD. When you go and look in your enterprise registrations or in your app registrations, you'll see it here set up for your organization. When you go to in enterprise applications, when you go and look at Microsoft applications and you apply this, you'll see the SharePoint Online Client extensibility right here, and you can see what permission scopes have been requested there. But it's easier for you. It's in the SharePoint admin portal. So keep that consent in mind for the permissions that you're asking for. Now, there's something known as dynamic consent, where you can change your SPFX component, you ask for a new set of permissions, and you redeploy that component. It then goes to the SharePoint Admin Center, where it has to be approved, but it also has to be reconsented. So if you ask for another permission that requires admin consent, the admin is going to consent to it again. And that's the Azure admin, not the SharePoint admin, but the Azure admin that has to consent to that. Wow. Okay. So we looked at all that and we managed to do it in just about 45 minutes, which is the fastest I've ever done this. Probably there are a lot of questions here. I will stick around for the next session and lurk in the chat. So if you have any questions, please put them there and I will be happy to respond to those. Again, thank our sponsors. Thank you to everyone for joining us for this wonderful event. And thanks to the organizers for doing such a great job in putting this together.
Okay, thank you so much, Eric. And let me say that after the initial problems with the sound, your session was absolutely fantastic. Okay, so thank you so much for sharing with us. Checking the chat again, and we'll still not have any questions. So we have a few more minutes. If anyone has any questions, just please just use the chat, and Eric can just answer all the doubts that may arise. But so far we didn't get nothing. I don't know, Rodrigo, if you have any questions. You have been very active in the chat. Is there anything that you want to ask to Eric?
No, not really. That's really. I was asking to take to get them a picture. That was the deal.
Yes.
Everybody turn their camera on.
Yeah.
Yeah. So I will suggest that at this time we can just use the together mode.
Everybody turn their camera on. Everyone who's listening. Come on.
Oh. Camera guys. Portuguese do it better. Come on.
Let's get them all in there. Everybody's shy today, Rodrigo.
Yeah.
You think? Let me try to get this picture. Else
Do you take the screenshots, Rodrigo?
Yeah, I'm taking it. Yeah.
Okay.
More guys, please. More guys.
Come on. Where's everybody?
There you go.
Okay.
It looks like they're not joining.
Now, just 1 second. Another one, because I think someone else had it too. You're doing the gestures with your hands.
Joe is there.
This is. Another one. Quickly. Sorry, Carlos.
Go ahead.
Okay, that's it.
Do we get it? All right.
Yeah, kick the cover. Yeah.
Perfect. Okay, Eric, thank you so much again.